Hey everyone, this is You Can Beat Mechanics CAD Cheater. Today we're going to do the CSW pin channel model. So here's the model, and this is how it will look like and turn out at the end. So load in SolidWorks and open your part. So before we start, let's look at the equations we need to add. So go to equations on the tool section, add all the equations you need to add. Make sure when you enter A, include the ×2 because we're going to be working with diameter, not with radius. So that's one thing you have to note right now. But yeah, once we're done, now let's go on the front plane. So let's just do a circle and make this 57.17. Yep. Now we make a couple lines stretching out just to get the general shape of the pin channel. 1, 2, make sure it's vertical and horizontal. 3, 4, don't make sure it's a line, just keep the lines straight out but not connected to anything. Once you're done, we'll smart dimension this, select the center and that point, and make this equal C. Do the same for the bottom one, 1 and 2. The bottom point below, we have to make sure this one equals 13. Yep. And now let's connect this line going down from the circle to the vertice on the left and make this equal to C. I forgot to include C on the diagram, so just bear in mind it is C, so 82. And there we have it. Oh, and the angle as well. Select both this line and that line and make it equal 30 degrees. Now to make our arc, select the 3-point arc. Connect this line with that line and just enter it. And now make the dimension equal to C. Now select this line along with this line, the vertical one, and make it tangent. So now it's fully dimensioned. Go to extrude. You see here it's extruding the wrong way. We want it to extrude backwards. So flip the direction. Make sure it equals 231 for our diagram. Your diagram will be different. Select contours and the shape should come out once you select it. So now let's select the face that we were originally working on and make a new circle. Select the circle, select it from the center origin, and now make this equal A. We already did the equation math, so the calculations are already made, but if you haven't, just do A times 2, or 42.5 times 2. Now to extrude, so make sure that when you look at your diagram, you make it equal the distance that it shows in your diagram. Now we're going to do the slot cut below, so make sure that it does not connect to the midpoint. We do not want that. So make it horizontal and expand. Let's try that again. Horizontal and expand. And then we'll dimension this using the smart dimension tool. So select this bottom and now equal that to 5. Make this 114 and the radius 11. Now let's cut this, and our distance is B. So get the angle right. B, yep, that's correct. And then let's go for the top cut, the rectangular cut at the top. So we use the rectangle corner tool and we're going to make this distance 38 and then use this to make this distance 33, and then let's cut that now. extrude cut. Make that equal B. There we go. Now we'll select the face that we were originally working on. Make sure that you make a line perpendicular. Sometimes it doesn't come out right. Click on it and you should see a yellow line. And make another line going out and make sure that's perpendicular as well. And do the same for the remaining section over here. There you go. Okay, so now let's dimension this. This would be 82. But we can just divide that by 2 because we're using half of its dimension. Yep. And we can just write the same for this one, just 41. And make that equal 51. Now we need to angle this so you can make the new face. So this will equal 38. And now just select this arc and make it into a converted entity. And now we'll select the trim tool and cut off the bits we do not need. And we should have our new face here. And now the final part is to extrude boss this by 33 millimeters. So select the extrude boss. And select the amount. And there you go. So in your final section, make sure you change the material to 106 alloy and check the material properties to answer the question. And now in the exam you might have a new question where the variables have changed and there's a new variable added. So make sure, let's go back to SolidWorks and add these new variables. We have here D equal to 5 degrees, so we need to add that in. So now go into the equations table. You can also go on the left hand side. You should see it displayed here. So just change your variables. So our A value is changed, and let me check that right now. Once you're done, make sure you add the new variable as well, where our D value equals 5 degrees. Click OK. Usually you can just hit rebuild, but I'm just going to show you the longer way for people who may not know how to do it if it's not working. So let's go here, let's go into our first sketch, let's edit everything. So this was C, our new C value is now changed, so it's 83. Let's change that, make sure that's C as well. Yep. And the arc has to be 83 as well, so C again. Yeah. So now let's move on to the next section. So let's edit the circle diameter. So it's no longer 85, it's the new one. So we have 95. Click enter. And we should see the new cut at that distance. Yep, now it's different now. Now let's go to the slot cut and then let's go here. Let's change it to the new B variable value. It's now changed, and now let's go up here. Oh wait, yeah. So we need to go to edit feature. Yeah, make this 5 degrees. So make that equal D. You can see the difference here once I click off and click on, and there you go. I have made a mistake. I did not include the distance cut for that as well. That's meant to be the new B variable, which is, I forgot to change that. But if you can, make sure you change the extrude cut for that variable. And yeah, so now just include the material. Alloy 106. 1060. And there you go, there's the material properties. Make sure if you see your answer on the question and it matches it, then you done it right.